Hello friends, today we are going to learn about elution in chromatography column. Okay, so we already had understood about what is column and understand about the classification of chromatography, and we also understand about what is the column chromatography, and we have learned that there are different type of a column chromatography. Now we are going to learn about a topic which is elution in chromatographic column. Now what is elution? It is a process in which solutes are washed through a stationary phase by the movement of a mobile phase. That means the solute, that means the component of a mixtures are washed through a stationary phase by the movement of mobile phase. That means where the mobile phase is moving through the stationary phase, at that time the component mixtures is being carried by the flow of mobile phase is actually washed through a stationary phase. Okay, now what is eluate? The mobile phase that exits the column in terms is termed the eluate. The mobile phase that exits the column is termed as eluate. So whichever mobile phase, okay, leave from the column which is a stationary phase is termed as elevate. Whenever the mobile phase will leave out of the column stationary phase, okay, which is in the solid form or liquid form, okay, when the mobile phase move out of the column it is termed as eluate. Okay, now what is eluent? It is a solvent used to carry the component of a mixture through a stationary phase. So what is eluent? It is a solvent used to carry the component of a mixture through a stationary phase. So this eluent, which is actually mobile phase, will carry the mixture of component, okay, and pass through this to the stationary phase. Okay, now here is a diagram about the elution. That means how the mixture, how the component of a mixture which is in the which is termed as a plus b, which is our sample, how this component of a mixture is separated through the packed column of stationary phase by the movement of mobile phase, that we are going to know in the terms of a time. Now this is t0. That means we are going to we are going to put this we are going to put this mixture of component as a sample, so it gets separated. So here we are going to pour this sample, which is the mixture of component, into the packed column. Now once this mixture of components is absorbed by the solid phase column, okay, at that time this mixture is divided. Can you see A and B? Both of these A component, B components are actually separated. Okay, when this mixture of component, okay, at T1 A and B mixture of component, these two different components are divided at T1. Okay, later after some time these A and B different components have some little space. That means they are actually getting separated. Okay, they are being separated. Then later after some time, at time t3, a component will come out, okay, and the b component is separated is separated very far from component A. That means A and B are completely separated at T3. Okay, that means the separation between the component of a mixture is successfully separated. So first component which will come after the column will be the component A. Then once the component A is completely move out of the column, then afterwards after some time at the T4, B component will also be move out of the component. So you can understand how the mixture of component is divided Okay, how this mixture of a component separated, okay, by this diagram. Okay, and this diagram is showing it very clearly. Okay, so what is it showing? The diagram of separation of a mixture of a component A and B by column elution chromatography. Now, after the separation of component mixture, what we can observe through this graph. Now this graph, okay, now this graph where the y-axis is the concentration and x-axis the distance migrated. So what we can observe that at the time t1, means at the initial timing, both A and B were mixed together. Okay, both A and B were mixed together. Okay, so at at the time t1 it was not separated. Okay, both these components were together as a mixture of component. Okay, then after some time, when these A and B started to separate themselves with each other, then later at T2, as you saw in the diagram, A and B, both these component separated from the mixture, and we can see that the distance migrated. Okay, here at T2 both A and B components are separated successfully. Okay, and here we can see that first a component will move out of the column once completely once the concentration of A is completely came out of the column. Afterwards the B component concentration will come out of the column successfully. So this is B concentration profile of a solute. Bands A and B of a two different times in their migration down the column in figure A. The time T1 and T2 are indicated in the figure A. Okay, now here is another graph. Okay, yes, now this graph is very much different than the just now we had a. Now this graph is very much different than the earlier graph. Okay, now here is x-axis is the time and y-axis will be the detector signal. Okay, so what does it show here? This actually graph is also known as chromatogram. Okay, chromatogram, that means this graph will be produced after the complete elution in column chromatography. So what this chromatogram is talking about, the detector signal at the various stage of elution in figure A, it is chromatogram. Okay, so at T0, see, see at okay, so here this is the T0. Okay, so at T0 both A and B component were mixed together. Okay, see, A and B component were mixed together, so nothing separation was happening. Okay, then later at T1 A and B component were actually separated, but not much, not so separate, not so successfully separated. So this is T1. Then at T2 this component A and B a little bit are separating to each other. Okay, still it is not successful separation, but at T3 we can see that both A and B are separated to each other. They are further with each other because we can see the gap. This gap is the packed column of stationary phase. So A and B are successfully separated. When it is successfully separated, when the when the concentration of component A is completely moved out of the packed column. Okay, and the B component is separated and it is much further away from the A. So here is So here in this graph, this is the T3. Here in T3 we can see A and B components are separated, and as you saw from the T3 that the component A concentration is moving out of the column first. So first at T3 A component was separated, then so at the T3 component A concentration was completely moved out of the column. So at time T3 component A was first component which moved out of the column, which means this is the first component which elevate out of the column. Then at the T4 you can see that the component of A is not there anymore because it's already moved out of the column at the time at the stage of T3. Okay, so at the T4, which is the last stage, at that stage the component B concentration is completely moved out of the column. So we can see at T4 component B is completely moved out of the column. So this is the stage that how the mixture of component is separated in terms of a time and detector signal, which is the chromatogram. Now what is the chromatogram? It is a plot of some function of solutes concentration versus the elution time or elution volume. So what is it? It's a graph in which is plotted with the concentration solute versus the elution time or elution volume. Most oftenly, elution time will be used as a x-axis. So we are going to learn more about the chromatographs.